Good morning, good afternoon, and good evening, everyone. Dear authors and invited guests, welcome to Technical Session 13A. I'm Sanskriti Kamkar and I will be moderating this session. On behalf of the Global Knowledge Research Foundation and GR Scholastic, it is my pleasure to welcome you to the last day of the 11th International Congress on Information and Communication Technology, that is ICICT 2026 in London, UK. I hope you find today's session engaging, informative, and insightful. In this session, we have six presentations. Each presenter will have 12 minutes for their presentation, followed by 3 minutes for Q&A. I will give a gentle reminder when 2 minutes remain. I request all participants to stay connected until the closing remarks. If you have any questions or updates, please feel free to share them in the chat box. I would also like to apologize in advance for any mispronunciation of names during the session. Before we begin, I would like to introduce our session chairs. First, we have Dr. Supriya Sabre, who is an assistant professor at MIT Academy of Engineering, Pune, specializing in computer engineering and IT. She is known for her work in artificial intelligence, machine learning, and deep learning. She's an active researcher and faculty member at the college, contributing to its academic profile, particularly in core IT areas. Welcome, ma'am. Would you please like to share a few words with us?
Yes, thank you, Sanskriti. Good afternoon, everyone. I'm Dr. Supriya Sable. It's my privilege to serve you as a session chair for this session and virtual Room 38 at the 11th International Congress on Information and Communication Technology. I extend a warm welcome to all the respected speakers and participants joining us from the different parts of the world. This session brings together valuable research contribution in the field of information and communication technology, and I am confident that the presentation will be provide meaningful insight and stimulate the productive kind of discussion here. Thank you.
Thank you for encouraging words, ma'am. This session is co-chaired by Dr. Sarbhagya Ratna Shastri, who is an assistant professor of electronics engineering technology in the Department of Mathematical Sciences at Eastern New Mexico University. His research focuses on applied artificial intelligence and modern computing, with particular emphasis on machine learning and deep learning, as well as Internet of Things and related emerging projects. Welcome, sir. Would you please like to share a few words with us?
Yeah, hello everyone. Welcome to this session. So I'm Sarvagir Ratnasake. I'm an assistant professor at Eastern New Mexico University, and I'm looking forward to this excellent lineup of the presentations today. Thank you.
Thank you for your kind words, sir. Now let us proceed with the presentations. First, we have Henry N. Roa, who is presenting a scalable blockchain-based e-voting system, architectural design and performance analysis on Solana.
Hello, everyone. Thank you very much. I will start my presentation. Give me a second, please. Okay, can you confirm that you are seeing my presentation?
Yes, it's visible.
Yeah, okay, thank you very much. Okay, good morning, everyone. My name is Henry, and today I'm going to present a research titled A Scalable Blockchain-Based E-Voting System, Architectural Designs and Performance Analysis on Solana. This work was developed at the Pontificia Universidad Católica del Ecuador in collaboration with the Universidad San Francisco de Quito. We are very excited to share our findings with you at ICICT 2026. Here is the outline for today's presentation. We will start with the introduction and motivation, then review the related literature, walk through our system architecture, present the results, and performance analysis, discuss implications and limitations, and finish with our conclusions. Let us start with the motivation. Traditional voting systems face three major challenges. First, security vulnerabilities. Many systems rely on centralized infrastructure, which creates single points of failure and is vulnerable to manipulation. Second, lack of transparency. When vote counting is done in a black box, citizens cannot verify the results, leading to distrust, third, high operational costs. Physical infrastructure, paper, and audits are expensive. Electronic voting systems promise efficiency, but they often introduce new cybersecurity risks. This leads us to our central research question. How can blockchain technology enhance the security, transparency, and reliability of elections? And what are the architecture and performance implications of building such a system on a high throughput platform like Solana? Previous research shows that blockchain technology has four key properties that make it ideal for e-voting: decentralization, immutability, transparency, and smart contracts. However, the choice of blockchain's platform is critical. Comparing Ethereum and Solana, the differences are dramatic. Ethereum can process about 15 transactions per second, while Solana achieves up to 65,000 TPS. Transaction costs on Ethereum can be very high due to gas fees, while Solana costs less than 1 cent per transaction. Solana also has sub-second confirmation times versus 15 seconds for Ethereum. For these reasons, particularly throughput, cost, and RAS memory safety, we selected Solana as our platform. Previous efforts like Ethervote and NetVote were limited by Ethereum's scalability. Our work addresses this gap. Now let me talk you through the system architecture. Our design is modular and follows a hybrid approach. The front end, built with Next.js and React, provides the user interface for three roles: administrators who manage campaigns, voters who cast ballots, and auditors who verify results. The backend API using Node.js and Express acts as a security intermediary, managing user registration and campaign metadata that do not need to be stored on the blockchain. The smart contract is the core of the system, implemented in RAS using the Anchor framework on Solana. It enforces selection rules, campaign creation, voter authentication, the one vote per user constraint, and immutable value recording. Finally, an off-chain database using Supabase stores no critical data, reducing blockchain storage costs while maintaining overall system performance. This hybrid approach is key: on a chain for trust and immutability, off chain for performance and efficiency. Our system is organized around five functional modules. Campaign management allows administrators to create and configure elections. Voter authentication uses digital wallets for security identity verification. Vote casting is enforced by the smart contract to allow exactly one vote per authorized user. Results are synchronized in real time between the blockchain and the database, and a public audio module lets anyone verify the vote count at any time. The voting workflow is straightforward. The voter connects the Phantom wallet. The front end creates a transaction which is signed locally, so private keys never leave the user's device. The transaction is sent to Solana. The smart contract validates eligibility, increments the on-chain counter, and the audit module confirms the recording. This entire process happens in under 1 second. Let me share the results. First, our performance numbers. Both transactions were confirmed in less than 1 second. The cost per vote was less than 1/10 of a cent, fractions of a cent, making it economical, feasible to scale to millions of voters. And 100% of duplicate and unauthorized votes were correctly rejected by the smart contract. Our unit tests confirmed all core election rules: campaign creation, the one vote per user constraint, rejection of duplicate ballots, and correct error handling all passed. The control simulation on Solana DevNet validated the entire system end-to-end. Multiple voters participate simultaneously. Both tokens were correctly ISO and burned, and the on-chain counters stayed synchronized with the off-chain database throughout the simulation. Even under peak activity, there was no sign of network congestion. These results confirm both functional correctness and strong scalability potential. Our findings have four key implications for ICT infrastructure. First, scalability. This work demonstrates that blockchain is viable for high performance, distributed application far beyond finance. The hybrid design pattern we use can be applied in healthcare, supply chain, and other domains. Second, cost. Solana subsent fees make blockchains voting economically competitive with traditional centralized systems, especially important for developing nations. Third, trust. Blockchain shifts trust from a single central authority to a distributed, transparent network. This is a fundamental change in how a democratic process can be secured. Fourth, open source. Publishing or implementation enables independent verification, which is essential for public trust. One important limitation to acknowledge, our validation was done in a controlled simulation. Real-world election conditions with million voters, network attacks, and legal constraints represent an important next frontier. We want to be transparent about the current limitation of this prototype. The first is identity verification. Digital wallets are not sufficient for real elections. A production system needs robust identity mechanisms to link each voter to a unique digital credential. The second is about privacy. While wallet pseudonymity provides some protection, full ballot secrecy will require advanced cryptography techniques like zero-knowledge proofs. Third, our simulation was small scale. We need large-scale stress tests with millions of participants to truly validate performance. And fourth, we did not address external cybersecurity threats like denial of service, attacks targeting voters' device. For future work, we plan to integrate zero-knowledge proof for privacy, conduct large-scale stress testing, develop a robust digital identity system, and explore the legal and compliance frameworks required for a real-world deployment. To conclude, this research has demonstrated four key findings. First, technical feasibility is confirmed. A blockchain-based e-voting system on Solana works, and it works well. Second, Solana is the right platform for this use case, with sub-second latency, near zero cost per transaction, and the safety benefits of Rust. Third, the hybrid design pattern is the architectural key, combining on-chain smart contracts for trust and immutability with an off-chain database for performance. Fourth, and most importantly, blockchain technology enables a fundamental shift on how we think about democracy processes, from trusting a central authority to trusting a transparent, publicly auditable network. Our open source prototype is available for independent verification. We believe this work provides a solid foundation for future large-scale decentralized electoral system. Thank you very much. I'm happy to take any questions.
What mechanisms are used to prevent the double kind of voting or unauthorized voting in your system?
Sorry, I couldn't hear clearly. Do you have a question?
What mechanisms are used to prevent double voting or unauthorized voting in your system?
I'm really sorry, Supriya. I couldn't understand the question. Please, could you write the question in the chat?
I think C is asking which methodology that you use for the for detecting the duplicating unauthorized voting.
So what were the, sorry, the?
So, what mechanism are you using to detect the duplicate unauthorized voting the votes?
Well, during the implementation, we have this database in which we are recording in real time what is happening in the blockchain. So when the voter try to use the application, this try is recorded in the database, and we contrast the ID that we provide for that voter. When that happens, so the system don't allow to the vote pass to the database.
Uh,
So it's a
Okay,
check.
so
It's a check with the
yeah,
with the database.
Yes, yes. Okay.
okay. So you said you apply the blockchain algorithm, but is there any specific algorithm that you use, or the combinations of multiple algorithms in the system?
Um, no, well, really, Solana has he unique. It's a unique blockchain, right? So it's like Ethereum. He has his particular benefits. So we just use Solana, and we
Oh, just
contrast
only
with
this.
Ethereum. Yes.
Yeah, yeah. Thank you. Nice presentations. Thank you.
Thank you very much.
Thank you, Mr. Henry, for sharing your work. Up next, we have Bao Yi Wu presenting AI-driven transformation in manufacturing, a multidimensional exploration of R&D efficiency enhancement in smart manufacturing. Ms. Wu, you may please share your presentation. Ms. Wu, I don't think you're audible to us. Is anyone able to hear Ms. Wu?
No, it's still not audible.
Ms. Wu, could you please screen share again and once check if your mic is on? Ms. Wu is dealing with the technical difficulties. Would Mr. Dr. Sharma mind presenting right now?
Thank you. Am I audible?
Yes, you are.
Okay, thank you. Okay. Can you see my presentation?
Yes.
Okay. Uh, thank you very much for having me this time. My name is Takuza Dondofema from Stellenbosch University. I'm a postgrad student in industrial engineering, and my research topic is mapping interventions and capabilities of actors for sustainability in underdeveloped communities, and it's a case study of Ranyaka. So my paper title was Mapping for Impact, a framework for sustainable development and inclusive governance for underdeveloped communities within ICT context. And that's me, Takuzwa, with my two supervisors. So the agenda is to have a presentation on the introduction, the problem statement, the aim, the methodology, the results and analysis, findings from the result analysis, gaps and emphasis from results, proposed framework, framework contribution, future work, and conclusion. So my introduction is underdeveloped communities face complex challenges, including poor, inadequate infrastructure, and limited resources, hindering progress towards sustainable development. So with the use of mapping tools and ICT, inclusive governance has become a viable strategy to deal with these challenges. So the problem statement is lack of comprehensive frameworks, lack of coordination within actors, and technological limitations. So the research aim is to develop an integrated framework combining mapping tools, participatory approaches, and ICT for inclusive governance. So the methodology that was used was a scoping review, and this is a Prisma SCR diagram, which is showing the collection process of data. So there was identification of databases, which was two, Scopus and Quick Scholar, and screening was done, which led to 66 records included for this research. So upon having a scoping review, this is a resultant analysis. So biblioshan was used to produce these results, and this is a thematic map showing 4 quadrants, and this was obtained through analysis of data from the literature. So these are the key findings, and these are the core themes with participatory mapping, stakeholder mapping, GIS, sustainable development, and these were the main that I identified, and more, which is not in this presentation, but these are the main core themes that were identified with their respective authors. Participatory mapping with that paper, which was written by Hossein in 2016, participatory mapping for community empowerment, stakeholder mapping, CPREL, which is a stakeholder analysis and social network analysis, GIS by H. Salim in 2025, which is the role of GIS in participatory conservation of heritage areas, which was a case study. Then sustainable development by Valencia 2019 et al. Adapting sustainable development goals and the new agenda to the seat level. And these were the gaps identified from the analysis and the emphasis from this. So the gaps identified technology literacy, lack of coordination within actors, funding constraints, and the emphasis was on participatory approaches, mapping, actor capability, alignment. So this was a proposed 4-phase integrated framework to be presented. So phase one, which is the foundation, we have the objectives phase. So on the objective phase, we need to define the human needs, community assets, and stakeholder roles to set the direction for the roadmap. Activities, we need to identify stakeholders, assess human needs, map community assets. Then on tools, we need participatory mapping, community workshops, we need to do SNA, which is stakeholder network analysis. An expected outcome on foundation, we need a stakeholder map detailing roles and capabilities and needs-based baseline of community priorities and assets. Phase two, which is the design phase, objectives need to develop synergic interventions and align actor capabilities to address identified needs. Activities, we need to design interventions, align capabilities, select mapping tools. Then on tools, we need to a mapping to evaluation grid, talk maps, intervention logic, GIS, QGIS, SWOT analysis, and expected outcome. It was a portfolio of synergic interventions linked to needs and capabilities, and actor-centric capability model aligning roles to interventions. Phase number 3, governance. So the objective is to create a governance mechanism to support stakeholder collaboration, accountability, and data handling, to develop governance structures on activities, ensure data integrity, facilitate collaboration, define accountability. Then on tools, CBPR, which is the collaborative governance indicators, the dashboards, needs-based matrices, participatory workshops, feedback loops. The expected outcome for governance is a participatory governance framework, which is clear accountability matrices tied to human needs. So the last phase, which is implementation. So on objectives is to implement, monitor, and refine the roadmap through iterative testing and continuous improvement. Activities to pilot pilot interventions, monitor impacts, iterate and refine. Then on tools, we need the base layer, GIS, QGIS, engagement layer, participatory mapping, PRA, relational layer, SNA, raw grids. And the expected outcome for this framework is a clear roadmap, which is defining what has to be done for developing communities. So the contribution of this framework, it is a human-centered framework developed to integrate mapping tools, ICT, and governance. And on mapping tools, the framework integrates GIS, participatory mapping, and stakeholder analysis to map community needs, actor capabilities, and interventions for transparent, evidence-based planning in resource-scarce settings. On ICT, the framework uses ICT to enable real-time communication, data management, and inclusive participation, allowing marginalized groups to engage in decision-making and monitor progress while optimizing resource allocation. Then on governance, the framework embeds inclusive governance to ensure accountability, equity, and collaboration by applying marginalized voices, aligning interventions with capabilities, and delivering adaptive, transparent strategies for sustainable development. So the future work for this framework is pilot testing in diverse underdeveloped communities, refine tools and training modules, develop SDG benchmarking mechanisms to evaluate the framework's effectiveness against key United Nations sustainable development goals such as SDG 1, which talks about no poverty, SDG 9, industry innovation and infrastructure, and SDG 11 for sustainable cities and communities. With this, I thank you, and I will bring to this presentation to an end and leave it to questions. Thank you.
Nice presentation. From my side, one question. What are the major challenges in implementing this framework in real world?
Um, so the challenges in implementing this framework in the world is, as I stated, we do have a lack of collaboration between actors. So those are challenges that we may face in implementing this framework. So there is a pure and need to make sure that actors or stakeholders are aligned together such that this framework can be implemented. So without actors, for example, community members, stakeholders like NGOs, we can't implement this framework. So with all this involved, this can be applied to the real world settings.
Hi. So you said this hasn't been implemented yet, yes?
Yes, yes.
So then how do you validate your framework then?
So validation has been done through data collection processes. So at the moment, I am working with, which is a case study, as I stated on my research, which is Ranyaka. So Ranyaka is focusing on developing underdeveloped communities. So we have been having stakeholder walkthrough sessions, meeting with them, discussing this framework. So they approved the framework and they stated that this framework can work for us. So stakeholder walkthrough sessions will lead to this framework implemented and work.
And how will it help in resource scarce settings?
Come again?
How will your framework help in those resource scarce settings that we?
Oh, this one it brings everyone together, which was the main which it brings everyone together. For example, the title which was for governance, so everyone will be brought together with this framework. So it brings everyone together and help in building uh, underdeveloped communities.
Okay, thank you.
You're welcome.
Thank you, Mr. Dhamma for your presentation. Now we have Vaini Wu presenting AI-driven transformation in manufacturing, a multidimensional exploration of R&D efficiency enhancement in smart manufacturing.
I'm sincerely apologize for the mistakes. So I'm going my presentations. Good afternoon, everyone. My name is Boyi Wood, and today I'm honored to present our research title, AI Driving Transformations in Manufacturing, Multidimensional Explorations of R&D's Efficiencies Enhancements in Smart Manufacturing. As artificial intelligence reshapes industries globally, the manufacturing sector stands a pivotal turning point. While most studies have focused on AI's role in production and automation, we ask different questions. What happens before production even begins? In the R&D phase, that is the questions driving this research. Let me begin with the context. Traditional manufacturing R&D face three critical bottlenecks. First, R&D cycles are extremely long, typically 6 to 12 months per product. Second, trial and error costs are high, often exceeding 30% of the total R&D investment. Third, data sales limited knowledge reels across the teams and the project. At the same time, mechanisms estimate smart manufacturing could generate over 1.3 trillion US dollars in value over the next decades. Yes, despite these enormous potentials, there is a significant research gap. Most academic studies concentrate on AI in production process, particular maintenance, question quality inspections, and supply chain. Very few have examined AI impact specifically on the R&D phase. This gap is actually what our research addresses. Based on the backgrounds, our studies is built by the three research questions. First, what mechanisms does AI improve does R&D's effectiveness in smart manufacturing? Second, are there significant differences in R&D's efficiency improvement among companies with varying levels of AI adoptions? Third, what challenges and managerial insights arise when firms integrate AI into their R&D process? These three questions form the background for our entire research designs. Now let me walk you through our analytical approach. These studies focus on announcing the correlations between AI's adoptions and R&D efficiencies across East Asian manufacturing firms. We employ two key statistical methods. The first is descriptive statistics, used to summarize the characters of our 121 samples, including industries distributions and averages AI's adoption levels. The second is the one-way ANOVA, used to test whether there are statistically significant difference in R&D's efficiency outcomes across different AI adoption levels. It is worth noting that we deliberately kept the methodologies accessible. We did not use complex machine learning models. This allows our findings to be transparent and reproducible, which we believe stringes and rather than limited the study's credibility. Let me now describe the data collections process. The research was conducted over the 6 months. Let me describe the data collections from the research was conducted over the 6-month period. We distribute 210 questionnaires to manufacturing firms across the East Asians. 120 village response were retired, yielding a response rate of 57.1%. To complete the qualitative details, and we also conduct 12 semi-structured interviews, each lasting 45 to 60 minutes. The samples was stratified by the first size, 40 large firms with 1,000 or more employees, 15 million firms with 100 to 999 employees, and 30 small firms with the fevers than 100 employees. This mixed methods approach allows us to capture both statistical patterns and contextual insights from practitioners. Now let's turn to the results. Now, the heart of the research, our ANOVA's analysis conference statistically significant difference in R&D efficiencies across AI adoption levels, with p-values below 0.01 across all 4 dimensions. Let me highlight each findings. On R&D circles reductions, firms with very low AI adoptions achieve only the 5.1% reductions, while those with very high adoptions achieve 31.2%, a difference of 26.1 percentage points. On design qualities, the gap between very low and very high AI adopters was 22.9 percentage points, from 4.9% to 27.8%. On cost reductions, very low AI adopters reduced cost by 4.2%, compared to 24.5% for very high adoptions. On innovation space, low AI adopters correlated with 1.1 months of accelerations versus 6.8 months for high adopters. These results consistently relates that higher AI adoptions is strongly associated with a greater R&D efficiency gains across all dimensions. To summarize our core findings, amongst first with a high AI, we observed meaningful improvements across all 4 R&D efficiency dimensions. R&Ds were shortened by up to 23.5%. Design qualities improved by up to 80.7%. Costs were reduced by 50.2%, and innovations, diffusions, accelerations significantly. This results in eventually suppose the conclusions that AI adoptions plays a pivotal role in enhancing R&D efficiencies in smart manufacturing. I want to be transported these figures reflects the outcomes of observing our high adoption groups, not an overall industry of averages. Which brings me to the next slide on the limited. Like all empirical studies, this research has its limitations. We believe it is important to acknowledge these properties. First, on the samples representatives, electricity and automotive firms accounts for the 22.5% of our samples, which make limited the generalizabilities of our findings to other industries. Second, the framework is a case certificate. It was developed based on the participants' samples and the contents. First of the different scales and industries natures make exhibits different AI's adoptions and dynamic. Looking ahead, we identify three directions for the future's research. Longitudinal studies to exhibit causal eventuals behave correlations. Borders cause regional samples to improve external validities and comparative studies across firm size and industry types. We see these limitations not as a weakness, but as opportunities for the research committees to build up these foundations. In closing, these research contributions, multidimensional efficiency framework was supported by the impartial event evidence from the 120 East Asian manufacturing firms. We hope these findings offers broader theoretical insights and practical skills for firms navigating AI's driving transformations. Thank you very much for your attention and welcome your questions and feedback.
What type of data is required for implementing your AI-driven model, and how do you ensure its quality?
Thank you for raising this. The 23%. The figures on the conclusions slides reputations offenses outcomes certificated amount of high adopters and not an advantage across the full samples. And we acknowledge this based on the sales reports survival data, not objectively methods in the indicators. This is the why we list it as a limited and call for the longitudinal studies to the validate these figures through the objective measurements.
And what about improving innovations in model?
Thank you for your our ANOVA results established significant correlations, not casuals. We are careful not to overclaim. Reviews casuals is possible, and the high performance firms may have greater resource and incentives to adopt AI. This is why our future research sessions priorities longitudinal studies and checking the things firms before and after AI adoptions to enable stronger casuals in inference. Our contributions at this stage is to provide an imperfectly ground associative frameworks as a foundation for that future casual work.
Okay, thank you.
Thank you so much.
Okay, so my question over here is, what are the criteria that you have used to validate the response in the survey?
Uh, thank you for your questions. Um, this is the important questions about the measures of validity. AI adoption levels was measures using the self-assess like lifestyle skills from 1 to 5, and with descriptive audit at each levels. And level 1 is indicates not AI uses in R&Ds, and level 3 is indicative particles adoptions in select workforce, and level 5 is a reflects food AI integrations across all major R&D stage. We acknowledge that self-assessments introduce subjective responses may use different reference points to supplement the data with 12 semi-structured interviews to verify and contextual sales report levels. Develops more objects and creates space AI adoptions index reminds an important directions for the future research.
Okay, so apart from the electronics and automotive firms, which are the other domains that you have the data from?
Um, we are from the like the companies from the oh we have the more balanced samples, and with the electricity and the automotive, and we used to use the traditional manufacturing factors to be our sample, like the like the um, like the companies making the traditional the watch, or the more like the traditional manufacturing.
Okay, okay, thank you. Thank you.
Thank you so much.
Thank you, Ms. Hugh, for your presentation. Next, we have Manuel Aikun presenting numerical analysis, energy efficient packet size optimization in context of wireless body area network.
Good afternoon, everyone. Am I audible?
Yes, you're audible.
Okay, thank you. Okay, my name is Minya Lekun, and I'm from Addis Ababa University, Addis Ababa, Ethiopia. The title of my work is Numerical Analysis for Energy Efficient Package Size Optimization in Context of Wireless Body Area Network. We have delivered this paper in collaboration with my advisor, Dr. Yalan Zodnekash. I would like to give my appreciation for all the support and the collaborative work they have delivered to me. My outline will be, I'll go through quickly the background or motivation, the contribution of this work, the system models and analysis, results and interpretations, and at last conclusion and future recommendations. So background. the percentage of population over the age of 60 from overall population has almost doubled the past is proposed to be doubled by the year 2050. This demands high quality delivery of public health care, which derives the need for robust wireless body area network and wearable and implant medical devices which are efficient. The major challenge with wearable and implant medical device is their sensitivity to electromagnetic interface and the energy efficiency. Especially the implant medical device, their battery life should serve the whole overall lifespan of a device, which demands energy efficiency as a key item. As a solution, it's proposed to have a cognitive radio technology. Cognitive radio is an intelligent wireless communication system to mitigate an interference and improve efficiency of electromagnetic spectrum usage using an opportunistic action. So using cognitive radio, a given frequency band which has been used by a primary user can be used by a secondary user whenever the primary user is not using that band. This will improve the spectral efficiency. In addition, it can be used to mitigate the interference. So basically, we have the primary users and secondary users, which will be sharing a given band of frequency without interfering each other. In the context of wireless body area network, the selection of primary users and differentiating them from the secondary users will be the device mission criticality and the AMI sensitivity. So in this work, the electromagnetic interference sensitivity of wearable or implant medical devices is used to make a distinction between the primary or the secondary. So on a given implant, we will consider it electromagnetic. If it is electromagnetic sensitivity high, then we will use it as a primary user for that given bandwidth. The contribution for this work will be to numerically analyze the packet size optimization problem. So we'll be delivering formulas, and we also come up with optimal packet size in the case of wireless body area network. We also have put some comparisons based on the channel property, the user property and the channel property, how it will impact the packet size or the efficiency of a given wireless body area network. The scope of limitation for this work is considered only limited electromagnetic implant medical devices and wearable medical devices, which are specified in the research work. But in the future, multiple devices can be considered so that the analysis can be more precise. Also, this problem only considers the hospital environment, and it does not consider telemetry systems, which have their own bandwidth requirements, electromagnetic sensitivity requirements. In general, the wireless body area network architecture consists of this. So we have the biomedical devices, the hospital management system, telemedicine system. While when it comes to a 2 meter, within a 2 meter radius of our patient or a human, will be the device and sensors. That network will be a wireless body area network. So in this work, we have considered the EEG machines, the pacemakers, the ones you see here. You don't have to go to detail to them, but wanting to highlight the red ones, the red devices, implants are very high electromagnetic sensitive, while the green ones are lesser. So in this work, we consider the red ones to be the primary network users or network frequency band users compared to the green ones. Also here also we have one implant which is in consideration. We consider this because it has high electromagnetic sensitivity, even if it does not have a connectivity between our cognitive radio controller. Okay. So our topology will consider number of ports and number of channels and the bandwidth as a key items for our formulation. The system model used is a channel of relay feeding channel. The relay feeding is used because we don't have a direct line of sight between the sensors, the implants, and the controller BTS. Between the sensors and the BTR, we don't have that direct line of sight. So relay feeding channel, that model mostly resembles the scenario we have for wireless body area network. For the channel, also the binary FSK is used because we have near ground wideband channel is used, and it has low requirements when it comes to hardware. So it makes sense to implement this with a cognitive radio sensor network. Adding simpler demodulation for the binary key, no line of sight. So additional assumptions we made is the primary user traffic will be either on or off. We didn't consider any other complications, and independent and identically distributed model for the primary user traffic is considered. We also assume the primary user to be stationary and ergodic. This will provide us scalable and predictable statistical behavior over time for the primary user. So the optimization problem starts with our cost objective function, which will be maximizing the energy efficiency of a given transmission, which will enhance the energy transmission and the consumption reduction, or increase the reliability. The variable that we'll be using is the packet size, as we'll be targeting to work on the optimal packet size for energy efficient communication. Also, we have other constraints like acceptable interference level for the primary user. So whenever there is another communication, or whenever we allow other channels to use a given channel which is allocated for a primary user originally, we have to also think the acceptable interference level of the primary user. As we say, the primary users for this research are considered to be the highly electromagnetic interference sensitive devices. So this is the formula that we need to do. The efficiency will be, dependent on the overall energy consumption.
I'm sorry to interrupt you. This is just a gentle reminder that 2 minutes remain for your presentation.
All right. Okay. Thank you. Okay. So we use this spectrum sensing energy detection method to detect the probability of detection and probability of false alarm. And using the channel state probabilities, we were able to make this computation. Let me go a bit fast. The energy derivation is also used to make or to come up with this formulation of the optimization problem. So based on the optimization problem and this channel parameters, we have made the analysis. So the result will look like this. So one of the observations is whenever the sensing time of a given cognitive radio network increases, we have seen an increase in the detection and a decrease in the misdetection. Also, unfortunately, it also increased the probability of false alarm. So that's why we need a compromise or a balance or optimized point, because it's also increasing the detection while it also increases the misdetection. While we go from the probability of the channel to be on from 3 to 0.5, we also have observed the probability of the detection increases from 0.3 to 0.5. Another result in interpretation or we have observed is our objective function, which is a multiplication of the efficiency with the reliability matrix. It decreases with the number of nodes increases. So whenever the plan of the design of cognitive wireless body area network, cognitive-based wireless body area network is done, we have to consider the number of nodes. The higher the number of nodes will decrease the objective function or the efficiency of our network. We have to run. So this is the major contribution of this work. This is the optimization, graphical optimization method. We have this our objective function, efficiency times reliability, and we have the unload interference level. The unload interference level should always be lesser than the maximum unload interference. So the minimum of this, even if you see the highest efficiency for the packet size with lower packet size, because the interference level is high, we cannot do or we cannot use this. So the optimal will be the intersection between the 0 point and the interference, the relative interference level compared to the maximum allowed. And we have found out for the selected parameters and for the selected number of devices, the optimal packet size that should be used is around 50 bytes. This is our result. As a conclusion, we have demonstrated the packet size optimization. The same method can be used in different scenarios in hospital and telemetry to utilize or to come up with optimal packet size for energy efficiency in context of wireless body area network. We have also shown the primary user behavior, which is the probability on and off, and the bit error rate, which is calculated on the probabilistic feature of each channel or each channel state, are the primary factors for defining the energy efficient optimal packet size. Future studies can be done by considering telemetry systems with wider domain of implant medical devices and wearable medical devices. Thank you. If you have any questions or suggestions.
What parameters were considered in your numerical analysis?
The secondary user transmit power. The gain of the antenna gain property was supposed to be taken. So for both primary and secondary, these transmit power values are used. The known primary probability of a channel to be off and on is also selected. For this case, we have used 19. The channel bandwidth we have used. Also, shadowing variance and phase loss exponents, which are the main items, are also considered. These values are used from the relay fading channel and the real practice. Another work that has we have got these figures from another research paper. Yeah.
Okay, thank you.
Nice work, but I have two questions over here. So one is, how did you measure the energy efficiency for, let's say, optimization? And the
Sorry, can you
second,
repeat?
oh, okay, yep.
Can you please repeat?
Yeah, so how did you measure the energy efficiency for optimization?
Okay. So this is the energy derivation. So we have the theoretical power levels. So the power if you have in the time between two cognitive states we have. So the area under the curve, we consider it to be the energy used by that cognitive network. So for the cognitive radio network, we have multiple states. We are assuming from ready directly it can go to a receive, and with this is the area under the curve. So using this kind of calculations, we did a little calculated the energy.
Okay. And my second question is, I think you said you use the real light channel because there is no direct line of sight. But have you make an experiment using other wireless channel like Raytheon or log normal and see what's the difference or how much is difference over there?
It's a really good, important question. I didn't consider other methods, or I didn't simulate. I use a theoretical background because that's the sensor and the coordinator, there is a body part and all. So that direct line of sight is not there. That default assumption was considered. But thank you for the input.
Okay. Yeah, maybe you can check with the other wireless channel also.
Sure.
Thank you.
Okay.
Dr. Supriya, do you have any questions?
Yes, it's done.
Okay. Thank you for the presentation. Next, we have Sonia Verma presenting Teaching and Learning Languages Online, a review of challenges, technological integration, and the role of e-governance. I don't think you're audible, Dr. Sonia.
Am I audible, ma'am?
Yes, you're audible.
Yes.
Okay, thank you so much. Just give me a second. Yes, is it visible? My slides are visible.
Yes.
Yes, thank you, everyone. Thank you for giving me the opportunity to present my paper on teaching and learning languages online, a review of challenges, technological integration, and role of e-governance. So basically, this paper focuses on how AI, how the online learning is transforming the new pedagogical theories, and this PowerPoint, the teaching and learning languages online, a review of challenges, technological integration, and role of e-governance presented. Provides a comprehensive review of how online languages education evolved rapidly after the COVID-19 pandemic and how it continues to transform through technological and governance integration. So this is the abstract of the paper, that COVID-19 has accelerated the transition of language education to online platform, resulting in teachers and students having to adapt rapidly and without adequate preparation resources. So the paper reviews the challenges faced in online language teaching and learning, highlights the responses to these challenges, and explore how educators and learners can be better supported in future educational crises. So the presentation explains that the sudden shift from traditional classroom to digital platform exposed structural weaknesses such as digital divide, poor infrastructure, limited teacher preparedness, academic integrity concerns, and low student engagement. However, it also accelerated innovation in AI-based platforms like Coursera, and Babel, pushing language learning towards a permanent hybrid and technological driven model. So this PPT is organized basically three interconnected and analytical lenses. The one is the pedagogical transformation. The second one is the technological integration and the e-governance support. So this is what the background and rationale. COVID-19 transformed traditional classroom into the digital learning spaces. And this is what I mean, what is the need for equity, governance, digital ethics, and sustainability. So the aim of the study, basically, it traces a clear evolution between 2021 and 2025. So this is a review paper. So initially, education functioned under emergency remote learning when pandemic hit, then stabilized through learning management system, later integrating MOOC and structured digital strategies, followed by the inclusion of generative AI tools, and eventually that is moving towards AI tutor, AR VR based immersive environment, dashboard, and e-portfolios, and theoretical foundations such as experiential learning, connectivism, collaborative learning, and motivational theory support this shift, emphasizing interaction, engagement, and learner autonomy rather than remote grammar based instruction. So this is what the three analytical lenses. So if we talk about the key challenges, so what are the key challenges in online learning? As we all aware that yes, digital divide, infrastructure limitation, lack of teacher preparedness, academic integrity concerns, student motivation and engagement issues, legal and privacy challenges as well. So this is what I've presented this review from 2021 to 2025, that how that evolution of online learning took place and how it has become now popular worldwide, or we can say it globally. So this is what the theoretical framework which I have presented. That is number one, this learning by doing. This is the experiential learning. Learning through connection, that is the connectivism. And learning by communicating, that is collaborative learning. And the motivational theories, self-determination, engagement model, which focuses on interaction, practice-based learning, peer collaboration, emotional engagements as well. So if we talk about that is the role of e-governance, so a major dimension in the PPT, this PPT is the role of e-governance in digital education. So it argues that governance framework ensure transparency, accountability, attendance tracking, academic integrity, and equitable access. Indian government initiatives such as SWAM, Diksha, and the National Digital Library of India are presented as an example of national level digital transformation. These initiatives provide multilingual access, subsidized content, and digital infrastructure support, helping bridge educational inequalities. So this is what the government initiatives, if we talk about it with the Indian context. So these are the ICT tools, that is the video conferencing, languages app, digital libraries, smart classroom, chatbots, and gamification. So this is, what the ICT tools which we are using to incorporate online language learning. And these are the ICT tools which is strengthening the online learning languages pattern. So this is the integration of, AI, NLP, and IoT. Since, we are the four authors of this paper, and this technical part is taken by co-authors. But yes, being a faculty of humanities, I would try to explain my best so that the purpose of presentation may fulfill. So this is technologically, the PPT explains the integration of artificial intelligence, natural language processing, and Internet of Things into language education. AI enables adaptive learning, grade forecasting, and chatbot tutors. NLP supports automated writing evaluation, sentiment analysis, and summarization. And IoT technologies contributed to smart classroom and engagement monitoring. So this is, the outcome is a data-driven, personalized, and interactive learning ecosystem. So this is what the integration of all these three. And these are the suggested technological models and ethical and governance consideration, that is data privacy and protection laws, fair AI usage policies, inclusive infrastructure, alignment with sustainable development goals, And these are the key findings. That is, online language learning is now permanent education model. This is not the alternate one. AI in hybrid system improve personalization. One can do, learning at their own pace. E-governance enhance transparency and service delivery. As at least government is there, the governance is there to keep an eye, to keep a check of the online languages tools. Infrastructure inequality remains a major challenge, and need for global collaboration and inclusive policy framework. So this is what the conclusion, that online language learning must integrate AI innovation, ethical governance, socio-cultural inclusion, sustainable infrastructure, future focus, that is AI tutors and AR VR expansion, policy-backed digital equality, skill to employment pathway. So basically, the final message is that digital language learning should not be the technological advance. It must be inclusive, ethical, and sustainable. So thank you. Now I would invite the questions, please.
What infrastructure is required to successfully implement this online language learning, especially in a rural areas?
Yes. So, ma'am, the government has taken a lot of initiatives. If I talk about the in the Indian context, so the government initiatives such as SWAM, Diksha, National Digital Library of India's are presented as an example of national level digital transformation. And basically, these initiatives provide the multilingual access and the content, which is the bridging the gap between this educational inequalities.
And what are the different challenges do teachers may face while adopting this kind of technology for language teaching?
Yes, ma'am. On a very initial phase when COVID hit the world, it was difficult for the teachers as well to incorporate, the online languages model into their teaching pedagogy. But yes, eventually we learned learned the challenges and various tools such as Filmora, and there are various tools that through which we can make our PPTs and our online languages and our content in a flexible way so that one could access the content at their own pace.
Okay, thank you. Nice presentation.
Thank you, ma'am.
Yep. So during the research process, but like nowadays with the development of AI and let's say NLP, as you mentioned, do you think it is anything during the research have you found that says the necessity of learning the new language in the future with those high tech, let's say, language translator in real time? So do you?
Yes, sir. Yes, sir. Definitely, definitely, sir. We have to incorporate these new languages or the AI-based languages or what we can say that ICT tools in our, teaching or learning pedagogy. As we can see, we are the Faculty of Humanities. So earlier we used to teach the manually to the students. Now what we are doing, we are incorporating softwares to our students. So that they could make themselves more confident at wherever they are. And since we deal with the student and we deal with the class where we have 40 plus or 50 plus number of students in the class, so these tools, that this technology, the incorporation of AR VR models, that makes teaching and learning both the things easy, and one can enhance their skills, the student can enhance their skills by incorporating or by learning or by evolving with these ICT tools.
Mhm.
So it
Okay.
is imperative for teachers as well, sir.
Okay. Yeah. Thank you.
Thank you, sir. Thank you.
Thank you, Dr. Sonia, for sharing your work.
Yes, ma'am. I have another paper.
Yes, yeah. Dr. Sonia will be sharing her second paper, which is titled The Rise of Artificial Intelligence and Computational Social Science, a bibliometric review from 2013 till 2024.
Yes, ma'am. So my slides are visible.
Yes.
So this is again very good evening. In India it's 9 o'clock, and this is what the online learning, the ICT tools through which we are connecting globally. So it's a wonderful opportunity. Once again, thank you so much. So I'm presenting my paper, that is the rise of artificial intelligence and computational social sciences 2013 to 2024. Basically, this is a bibliometric review paper. So, in this paper, this presentation provides a deeper understanding that how uh, AI has transitioned from being a purely technological discipline to becoming a core analytical tool in social sciences. Earlier, social sciences and the humanities, theories, used to be taught manually. Now, what we are doing, we are incorporating AI, such as we are incorporating, various tools to make our content more comprehensive. So this is what I mean. We have reviewed a lot of papers where we have found that yes, AI is no longer only studied as a technology. Rather, it is actively used to analyze social behavior, government system, labor market, misinformation, inequality, and public policy. So such tool as bibliometric R, VUS viewer, site space, and LDA topic modeling help identify dominant research clusters like NLP and text mining, machine learning, prediction model, social network analysis, and AI ethics and governance framework. So the exponential growth model and bibliometric laws, Lotka's and Bradford's, further confirm the rapid expansion and concentration of AI-related scholarship in core journals and among highly productive authors. This presentation also, gives a paradigm shift here. I have mentioned, I guess. No. Let me explain this one. So if I talk about the background and research motivation, so this is artificial intelligence is transforming not only technology, but also social sciences. It is, though it is a technology, artificial intelligence is a technology, but somewhere or other, it is being incorporated in the social sciences text as well, such as politics, economics, sociology, education, public health, and it is shifting from traditional computation methods to AI-driven social research. Growing debate around ethics. If we are incorporating any research, or if you are making our pattern more artificial intelligence, so definitely there is a debate for ethics, algorithmic bias, governments, and regulations. So research objectives, this is the analyze AI integration into social science. This is, the review paper. And the earlier research, 2013 to 2015, in my research paper, I have focused on AI foundation ethics, and mid-phase 2016 to 2018, which is emphasizing on governance, surveillance, and policy. And around 2019, attention moved towards algorithmic bias and inequality. During 2020, AI was applied heavily in COVID-19 crisis management. And from 2021 to 2024, regulation, accountability, labor market impact, and responsible AI became dominant theme. So this progression shows that AI research in social sciences has matured from conceptual discussions to applied policy oriented and regulatory databases. So this is, the flow chart and system where we are collecting. This is the review paper, I should say. And the suggest approach employs a methodological pipeline that begins with data collection, preparedness, and then bibliometric indicators, network constructions, clustering, topic modeling, and interpretation as visualization. Next is, that is methodology. So this is, the methodology which we all have used. And growth trend, which I have explained. This is what the growth trend from 2023, and this is what the results of this exponential growth model. And thematic evolution, that is regulation, which I have explained. And this is the suggested mathematical and bibliometric model, which is explained by my co-authors, since they are purely technical, and I am, being the Faculty of Humanities, try to incorporate AI, social science, with NLP and the other technological models. So this is proposed by, this is the review paper. And major research domains, this is NLP and text mining, topic modeling, sentiment analysis, social media analysis, machine learning and prediction, network analysis, ethics and government. And this is, the paradigm shift that AI in research, AI research in social science has grown as exponentially. Clear interdisciplinary expansion across economics, political science, sociology, and 85% of research paper published in last 5 years as well. So shift from studying society using computation, studying society using AI, ML, and deep learning. And this is what the future direction, that strong AI regulations, ethical governance framework, responsible and inclusive AI integration, and cross-disciplinary collaboration. So this is what my paper is all about. So thank you so much for your patience. Questions, please. Am I audible?
Yes, you're audible.
Yes, ma'am. I have finished my presentations. I would request if is there any questions, please?
How AI is transforming the way of social science research it's conducted.
Ma'am, this bibliometric analysis, this is, demonstrating the growth and thematic diversification. But yes, it also reveals that AI in social sciences is still in a transition stage. The field is moving from exploration to consolidation. The major gap lies between is the theoretical discussion of ethical AI and practical, measurable government implementation, and additionally, more inclusive, global representative, and empirically grounded studies are needed to strengthen computational social science as a mature discipline.
Okay, so if you have to summarize your research and let's say mention one advantage and one disadvantage of let's say using AI in social science research, what would that be?
Sir, I would suggest that if you're talking about the one, both the points. So this
Hmm.
is limited global representation. Still,
Hmm.
it is in transformation stage. Social science,
Hmm.
the incorporation of these technologies to the humanities is still in a transformational age. It is yet to
Hmm.
be implemented full-fledged in the university's curriculum.
So
So,
what about in terms of the research? Like while doing the social science research, if we use the AI, does it have any advantage and does it have any disadvantage?
sir, there is one advantage using the use of technology. Definitely, it has its own advantage. But if we kill our creativity and will completely
Hmm.
depend on the technology, that can create a challenge to the young learners. So, what
Hmm.
is usually happening in the class? If you are giving them the assignment, they are presenting a wonderful assignment by taking the help of AI models. But actually,
Hmm.
when we ask our student to explain it, so somewhere there is a gap. So this is what there must be a clear understanding to everyone, the one to all the stakeholders, that technology is for the use, not for the
Hmm.
dependency. So
Hmm.
this is still in the transformation age.
Have you found any solution for this problem in your
Uh,
research?
no, not yet, sir, but yes. The gradually, the more we work on social sciences and technology, the more we'll incorporate the technology to the social sciences. So definitely, we'll get the results, sir. And there is, no problem where the results are not found. We'll get it.
Yeah, yeah, yeah. Thank
Yes.
you. Thank you.
Thank you, sir. Thank you so much. It was a nice interaction with you all. Thank you
Yeah.
so much.
Thank you.
Thank you, Dr. Sonia, Professor Shakisa, and Professor Supriya for this engaging discussion. And with that, we have concluded all the presentations for today. I'd like to thank all the authors for the excellent presentations and valuable contributions to this session. I also extend my gratitude to all participants for being a part of this international conference. I hope this session was informative and insightful. On behalf of the ICICT team, thank you for your continued support during the 11th edition of ICICT, as well as all the previous editions. We look forward to welcoming you again for the 12th edition in 2027. All presenters will receive the digital certificates via email within 2 working days. The publication is expected to be available within 7 to 8 months. We kindly request your cooperation with the ICICT 2026 team during this process. I would also like to thank our session chairs, Professor Supriya Sabre and Professor Sarbhagya Shakya, for effectively chairing the session. We now present a token of appreciation on behalf of Team ICICT 2026, the Global Knowledge Research Foundation, and our partners. Sarah, ma'am, would you please like to share a few words with us?
Clearly, thanks to all presenters for their very insight presentation and participation in this conference. I also extend my gratitude to organizer for providing this excellent platform for knowledge sharing. Thank you all and have a wonderful day ahead. Thank you.
Yeah, please
Yeah,
declare.
and thank you from my side also to all the presenters for their excellent contributions. The session was very thoughtful and engaging. Yeah, thank you. And thank you for moderating this session. Thank you.
Thank you for your kind words, Sarah. May I please request everyone to turn on their camera so that we can have a snapshot of this session. Thank you everyone for joining us today. I hope you all have a great day.